All right. Good evening, everyone. Welcome to this session on, let's say, API security in depth. We're going to talk about quite a few things today, and a lot of it will have to do with IdentityServer for customization, because it's a pretty extensive product with which you can do much more than just regular OAuth and OpenID Connect flow. We'll obviously also learn why those things are important. You can see my coordinates on screen. The important part is the GitHub link, because on GitHub you can already find the code for this session. It's the API security in depth repository. It's already all on there, so you can find it and have a look at it whenever you want. You will also notice during the session there is a lot, and I mean a lot of code that we will run through. So much, and I absolutely cannot type all of this. I'll have to be typing for half a day if I were to do that. Because, well, customizing IdentityServer often means working on the controllers and working on the views and adding them. But anyway, you'll see during the course. Also on that GitHub are quite a few open source projects that always need help. So if you feel like submitting a pull request or something like that, I'd be very happy. But anyway, let's start with the session. Let's have a look at what we're going to talk about. We'll start by learning what reference tokens are. This is just actually the easy part. It's pretty easy to code. But we'll start with learning what they are and how they can enhance the security of your application. We'll obviously also learn how to implement support for that with IdentityServer and in your API. After that, we'll talk about something that has to do with user impersonation. It's actually an implementation of a custom flow, which is often needed in enterprise scenarios or in scenarios in which you need API to API communication, so downstream API communication, in which you need to keep the user's identity set, so in which you need the downstream API to know the user's identity that's accessing the initial API, and so on and so on and so on. To be able to do that, you need to write a custom flow, or to be able to securely do that, you'll need to write a custom flow, and that is exactly what we'll do. And for that, we can use user impersonation semantics. Very much related to user impersonation, but not the same, is user delegation. It essentially means that I will be able to access an application on behalf of someone else, with the application still knowing that I am acting on behalf of someone else. So you somehow need a way to put that in a token or something along those lines. There are standards for that as well, so we will look into that. And then we're going to improve client authentication. You all know that in OAuth2 and OpenID Connect, you have a client ID and a client secret. That is client authentication. You need that to access, or often need that to access, the token endpoint. But the client ID and the client secret only get you so far. There are better, more secure ways of authenticating client applications, of which we will look into one. All right, so that is more or less what we're going to talk about. I do have to say, before we go on to the next slide, that I have been updating this session. I gave it once before, I think, at Techorama, so it was never recorded. So I'm pretty sure it should be new to most of you, unless you were at Techorama. And that was in October last year, I think. So I updated it last week to the new version of IdentityServer and the new version of ASP.NET Core, and so on and so on. And I did notice that in IdentityServer, there was, let me see if I can get this, like that, that in IdentityServer 4, version 4, which has just been released, there were a few breaking changes. So I figured that I would quickly run through the solution I have going here and look into one of the breaking changes that tends to get people annoyed when they update their existing IdentityServer implementation to the latest version. Let me just make this all a bit bigger. And that is how it handles API resources and scopes. So if you have used IdentityServer in the past, you know that it worked a lot with API resources. So you would define essentially a scope that would become the audience value and in the scope list in your access token, which would then be checked by your API to allow access or not. And that is an API resource. That is still the case. You can still define API resources as such. But the new thing IdentityServer 4 adds to this list is that you can now combine API resources, which essentially allow access to an API or not, with additional API scopes. And those API scopes allow you to have more granular access at the level of an API. So you will get an access token with the API resource you define, say API1 if you want an API name of API1 and you want to check whether or not the token gives access to the API. So you can combine that with more granular API scopes. I only have one for the demo, full access, but you can imagine scopes like read, write, stuff like that, or even more granular, which will now separately show up in your scopes list. So I thought it was quite a nice addition the IdentityServer team did, which allows for much more fine-grained authorization. But it is a bit confusing at first because API resources are not even used anymore in the default templates. If you start working with IdentityServer now, it's all API scopes, but in reality, I'd probably say define an API resource to access an API, define scopes inside that API, which you can use in your authorization policies. So that is one breaking change. The other important breaking change you will probably run into is that the part you're going to need this little piece of code for is that IdentityServer will no longer by default emit an audience claim containing the API scope, which is kind of annoying because a lot of middleware depends on the audience claim being there so it can check that. Well, you can override that behavior and it's actually overridden by default by setting emit static audience claim to true. All right, that is more or less the big changes in IdentityServer 4 that I ran into while updating this solution to the latest version. But let's see what else I have in my solution here. I have one client application, simply ASP.NET Core Web App, which already integrates using the best practice code flow with Pixie with the IDP. Client application talks to API1. Maybe I can make this a little bit bigger. Oh. Client application talking to API1. API1 talking to API2 to get that downstream API example I'm going to talk about later on. And all of those are secured, so in the same trust domain by this identity provider. And let me quickly run that so we can see what we're going to start from. That is slower than it should be. All right. So IdentityServer 4 v4. I have 4 users defined: Bob, Alice, Kevin, and Sven. We're going to use them throughout the session. And this is the application. So you see that there's nothing special about this at this moment. This is a simple code flow with Pixie protection. You get an identity token, you get an access token, and I write out the claims of the identity token. There's also a few buttons here which we will use throughout the session to call an API to API, and so on. So this is what we'll be working with. All right. So with that, I can go back to my slides, I think. Right. There we go. All right. So the first part was about reference token support. Now, what is a reference token and what is a self-contained token? Well, you can actually see those on screen. On the left, you have the access token you're probably used to working with. It is essentially a set of claims and an expiration date in a protected data structure. So it's a signed data structure that contains all the information that is needed to make sure you have access to the API or not. So in essence, all your API needs to know to verify this token or to validate it is the well-known document. So the API needs to read out the well-known document of your identity provider from which it can get the public key related to the private key the token is signed with. And that is all that is needed to verify this token. So it simply checks the signature, then checks whether or not the expiration date has passed, then checks the audience value, and potentially the scope and grants access or not. And that is pretty nice, actually. It means that you don't have a lot of traffic going back and forth between your API and your identity provider. In most applications I see, the well-known document which contains that public key is read out once when the API is starting up, and then maybe every few hours or so. The rest of the time it's working on a cached version. So that's really good to diminish traffic to your identity provider from your API. But, well, there's also a little problem with that. The self-contained token potentially grants access as long as it hasn't expired. So if you have a token that's valid for 60 minutes and someone steals that token, that person will have access to your API for 60 minutes because you cannot revoke self-contained tokens. There is no check to the IDP anymore at level of your API. So once a token comes in, it grants access or it doesn't once it has expired. And that can be a bit of a problem. Now you can diminish that to by keeping your access token lifetime low. But even then, you might want to have a way to revoke tokens ad hoc whenever you need to revoke them, whenever you notice a breach has happened, or whenever a person has to immediately leave the company and his access has to be revoked immediately because otherwise he or she might do bad things. And that's where reference tokens come into play. So if you look at the previous slide again, a reference token it's just an identifier, as you see. So this doesn't really contain any information other than a reference to the actual result of the grant. So a reference to what you see on the left, a reference to what's in the self-contained token. And that content is stored at level of your identity provider. So this is pretty nice. It means I can now revoke access at any given time, ad hoc, whenever I want. And I can do that by removing the grant result at level of the IDP. There are ways to do that in code, but often you might have an admin application that simply removes that from IdentityServer's operational database. So it can remove that ad hoc, which is pretty great. But there's also a disadvantage. It requires constant communication with the identity provider, because at the moment the access token comes into your API. Well, the API has to ask to the identity provider what is actually in that token. So that's called introspection. It has to call the identity provider to know what to do and whether or not to grant access. Now you can kind of offset that, and it's often offset a bit by caching the grant result. And that's done often, but then it's a matter of not keeping the cache too long, because otherwise you kind of lose the advantages of revoking ad hoc. What's often done is a caching time of about 5 minutes. But anyway, this is a pretty cool thing to do, and it can heighten your security. Now let's have a look at how we can do that. So where am I? I'm going to start at the level of the identity provider. So we're looking at configuration file. Of IdentityServer. Because we no longer want to use a JWT. Nope, we want to use a reference token. And to be able to use a reference token, or to be able to get the result, the actual result of the grant that's linked to the reference token, we need a secret, because the API needs to communicate with the identity provider to get that result. And to be able to communicate with the identity provider, you want to have a secret in place. So you simply add one simple line, API secrets defining a secret. That's one thing you have to do. Second thing you have to do, and we're looking at the definition of my client application here, is set the access token type to reference. So by default, it is set to JWT, which is self-contained. You can switch that out to reference. And that at level of the identity provider is all that needs to happen. Let me start that up. At level of the client, you don't need to change a thing. So that's good. If I log in now, once all of it's on screen, you can see that the access token is now just an identifier. It's no longer something that might look like something that is signed. No, it's just this identifier, and that's it. But if we now try to call the API, which I'm going to do, we run into a small issue. An internal server error in this case. Let's have a look at what is up in there. There we go. If you look at the exception we actually get, here we are, this more or less. You must either set the authority or introspection endpoint. Now, what might that mean? Well, I just mentioned that the fact that you're going to get the contents of your token from your identity provider and verify it like that, that is called introspection. And we also defined a secret, API secret for the scope. But we forgot to tell our API that it now needs to do that introspection. The API, in other words, still just expects a JWT instead of a reference token. So we can easily change that. At level of the API, I have added the access token validation middleware of IdentityServer. Let me put in comments, and I'm going to uncomment the reference token part. And there's only one thing that has changed here, and that is that the API secret is set to the API secret are inputted at level of the identity provider. So let's try that again. There we go. Let's try logging in as Alice for this one. Why not? And if I now call the API, I get back a result. By the way, I didn't mention this before, but what I get back from the API is simply a write out of all the user claims at level of the API. So that is this piece of code. So I simply select everything about the user and I return that. Like that, we can nicely see who is actually accessing the API, or in other words, who the API thinks is accessing it. That will become very interesting once we start with the multi-hop demos. But anyway, you see that we can, again, reach the API. And I think that we should also be able to see that it is indeed Alice who called the API. So I am calling the API on behalf of the user who logged in. And that's how easy it is to get reference token support. So that was quite an easy demo. But then the question becomes, when do you want to actually use this? So it has advantages, the ad hoc removal of ground results, but it also has disadvantages, the ongoing communication with the identity provider from the API. Well, a good rule of thumb is use reference tokens for tokens that leave the company walls. So what I mean by that is tokens that are, for example, exposed to your browser. Those leave the company walls. They end up at the machine of the client. So if a call has to happen from an Angular app, for example, that token has to somehow be it very short or very long. Some people put it in session storage. Some people simply fetch it from the server when they need it and shortly store it. But in any case, the token gets loaded on the client somehow. That means it leaves company walls. From that moment on, it's a good idea to use reference tokens. As long as the tokens stay inside of the company walls, so you're doing a call from a server to another server inside of your company, you're probably better off with self-contained tokens. If you do a call from a server to an API at a third-party server, the token is again leaving company walls, so it is a good idea to ask the third party to use reference tokens. So that is a bit of a rule of thumb in regards to using reference tokens. All right. The second part, that was impersonation or user impersonation for API to API access. And maybe I should start by explaining what exactly I mean by this. Oh wait, no, I think I forgot something. I've been talking about reference tokens and self-contained tokens, but I forgot to show you how you can revoke it. Wait, I'm going to show you that. I actually have a link revoke token on screen, so I created that link for something. So as I mentioned, you can revoke reference tokens ad hoc by looking at the database with operational data where the ground results are stored, IdentityServer database, and simply removing the line. But you can also do that from code, and that is the revoke token button here. So let me just click this, and that should have revoked the token. If I try to call the API now, I shouldn't be able to do that. And indeed, I am unauthorized because my token has been revoked. So this is how that actually works and how you can actually ensure that ad hoc access is removed. Now let's have a look at the output of IdentityServer. Let me see. Here we go. So what we see here, I should see a revocation, yeah. So I sent that revocation request about 8:30, and we see that the access token was revoked. I'll immediately show you the revocation request. And if we scroll down a bit to the moment where I've accessed the API with that reference token, we see that there was an invalid reference token passed through. So I don't get access anymore. And that makes sense because this is the reference token being revoked. To do that in code, I prefer using the identity model helper library, which is from the people that created IdentityServer. And it's essentially a bunch of extension methods on HTTP client, which make it easy to talk to an identity provider and execute OAuth and OpenID Connect related stuff. And I think I have the code here. So what you essentially do is, first, good rule of thumb, always load the discovery document to get to know the correct location of the access token, of the token endpoint and the other endpoints. So don't just hard code it. Maybe load the discovery document once and cache it, but don't hard code the token endpoints and the authorization endpoints. Just load them once and keep them somewhere. So for the demo, I just loaded it ad hoc. And then there's a very nice method, revoke token async from identity model. which allows me to input the address, in this case, the revocation endpoint, a client ID and a client secret. This is my web client's ID and secret. And I also pass through the token, the reference token I want to revoke. And that's actually it. So after you call that, you will get a response which will either say, oops, you made an error, or it will effectively have revoked your token. So that is how revocation ad hoc works. A good tip, it's a good idea to always, if you can revoke them, revoke reference tokens and refresh tokens once the user logs out, just to make sure that they don't hang around somewhere by accident. Just make it a good practice, on log out, revoke those tokens, and you're always good to go. All right, so I accidentally skipped that part, but now we can effectively go to user impersonation for API to API access. What I have on screen here is a pretty typical example of downstream API access. I have a client application, and the client application accesses API 1, and API 1 needs to access API 2 on behalf of Kevin, on behalf of the same user that accesses API 1. In other words, on behalf of the user that logged into the identity provider and thus logged into the client. Now, with this token, which has an audience value of API 1, I will get access to API 1, but I won't be able to access API 2. And that is a bit of a problem. Now, we can work around that. We simply need an audience value of API 2 in our token to be able to access API 2. So one way of solving this would be to simply let the client application request a token with 2 scopes that have to end up in the audience array, API 1 and API 2. That's easy to do and it works. You just pass through the token to API 1, you get access to that, and API 1 reuses that same token and passes it through to API 2. And this will work. But there's a bit of a problem with that, because by allowing this, you've just allowed your client application to directly access API 2, because your client now has an access token that grants access to API 2. And it can be that you want to allow that, but more often than not, this is something you want to avoid. You could, for example, have a single page app that accesses an API, which is a bit of a backend for front-end API or something that is only for that client, but you may not want to allow that client to directly access a more internal API that doesn't really give back or doesn't really give back just the information the client needs access to. It's a bit broader or something like that. So this is something you would want to avoid. What you actually want is that the client has an access token with audience API 1, and that API 1 somehow, in a way, can exchange that access token for an access token that allows access to API 2. But the important thing here is that this all happens on behalf of the same user, which means you cannot use a client credentials flow there. You often see that for API to API access, you would give your API a client ID and a client secret, and that can then easily be exchanged for an access token. The problem with that approach is that you will get an access token without a sub-value, so without a user. So there is no impersonation anymore. The second API loses notion of who the user is. And you often do need to know who that user is for downstream APIs. But how do you do this then? Well, we're gonna need a custom flow for this. And that's not a bad thing. In fact, OAuth2 was built with extensibility in mind. It is made for custom flows in a way, or it is made to be able to make custom flows. In fact, in a lot of clients I've worked for, we need custom flows, especially if it's a bit of a bigger company that's going to get needs a bit of more exotic ways of identifying users, or a bit of more exotic ways to expose APIs, to make applications, and you are quickly going to run into the need for a custom flow. The thing is though, creating a custom flow is creating a secure custom flow it's a bit scary. It's not something you want to just do from the top of your head and start designing ad hoc on your own. At least I don't want to do that. But luckily, for almost any use case, there are standards or standards underway. For this use case, for example, there is something called the token exchange standard. You can find it via the link on screen if you ever want to look into it. And it's essentially a standard built and created to securely, which tells you how to securely exchange one token for another token. And that kind of sounds like something we need. Because what we want to do is exchange a token, which is a token containing me as a user, for another token that impersonates that same user from that token. So the second token is still me. I simply impersonate myself. So we can use the token exchange standard for that. And we can use the impersonation semantics from that standard for that. What does that look like then? Well, this is a typical grant for API to API access. So this is what API 1 would have to send to get back a token to access API 2. A grant type, which is a fixed value, as you can see on screen, token exchange, is one of the possible ones. A bearer is another one, as you'll see. You also have to pass through the initial token, which contains a subject. So that is the token used to access API 1. And this should then result, well, you also have a subject token type, access token, and this should then result somehow in a token that gives access to API 2. Let's have a look how we can do that. Because obviously we need to keep this safe. We now know the semantics. People thought about that, so let's assume those are good semantics. But we still need to implement this in a safe way at the level of the identity provider. So let's start with that identity provider. Put that out of the way a bit. And to do something like this in IdentityServer, you're going to need to build an extension grant. And I've actually made one. So to create extension grants or custom grants, you would create a new class that implements the iExtension grant validator interface. This is one from IdentityServer. If we have a look at that, we see that that requires us to input a grant type. That grant type, that's coming from the slides, by the way. So we know what the grant type should be. And, or something along those lines. And it also requires us to input a validate async method. So it's this method that we will have to implement. And in this method, we will have to validate what's coming in. We will have to get some content out of it, maybe transform it a bit, and then return a new result, which means a new access token, so we can continue. So, as grant type, I inputted the value from the slide. As access token type, I inputted the second value from the slide. So this is the subject token type, actually, you see here. And in the validate async method, we're going to validate, first of all, this request. So we're going to check the grant type, we're going to check if a token comes in, and we're going to check the subject token type. And those are the first few lines here. So from the context, you can get to a lot of information. If you have a look at this, you can get the full request, which is the full token request that comes in. So that contains everything sent to IdentityServer's token endpoint. So all the information you need. First thing we do is check those three things. So we check the grant type, the subject token, and the subject token type. So far, so good. Then we check if the subject token type is the access token type. So if the subject token that is passed in is effectively an access token. If it isn't, we return a ground validation result of invalid request. And then here's the important part, and this is very important to do. We need to validate that access token. And for that, we can use a validator from IdentityServer. Again, the token validator is a built-in interface and implementation in the IdentityServer framework. So we simply inject that. And by calling validate access token async on it, passing through our access token, we will know whether or not the token is still valid. And what does valid mean? It means that the expiration date is checked. It means that the issuer is checked. More or less the same procedure you would see when validating an access token at level of your API. So if that checks out, we know we have a valid access token we can now exchange. So what do we want to return? Well, we want to return a new access token on behalf of the same user. So I need the subject from the initial access token. I get the subject value, and then I essentially, and I'll immediately get to all the comments I wrote there. Then essentially I can say, okay, I want to create a new access token with the initial subject as subject value and the claims from the initial token as claims for the new access token. So that is how easy it actually is. In regards to scopes, by the way, it is simply IdentityServer's default way of handling that. So you will immediately see that at level of the client, we will, at level of API 1, we will request scope API 2. This doesn't belong in this custom ground validator. It is simply handled by IdentityServer's other components. But this is a pretty simple example. At this moment, you can actually, and you can write that in this custom ground validator, and this is where some grounds become really custom. You can start creating additional checks. So you could, for example, say, well, I don't know if I simply want any user to access the second API. Well, at this moment, you can write code for that. You can check whether or not the user from the initial token is allowed access to the second API. And you know which API is asked to be accessed because you have the full request on the context here. So on this context, you have all the information you need for that. And something else can happen. You could say, well, I don't want all claims that are in the initial token to be returned in the second token. So you can do a bit of claims information. You can add claims, you can remove claims, you can change them depending on what your API 2 needs. And what is very interesting is that this ground validator nicely ties in with the IdentityServer framework. So if, for example, the initial token contained an email claim, and I simply pass through a ground validation result with a list of claims that still contains an email claim, but API 1 did not request the email claim for API 2, then that email claim will not be in API in the new access token. So, and it also works the other way around. So it really ties in nicely with the IdentityServer framework. All right, once you have that, you obviously need to register it. So for that, you call the add extension ground validator method on the builder. That ensures that it can be used. And then, well, at level of API 1, we're now going to need to exchange this. So we need a client definition at level of API 1, obviously. And that is what I used this API 1 client for. So I created a new client definition. And what is important here is that you see that the allowed ground type here is the token exchange ground type, the one we linked to our token exchange ground validator. So like that, it will know which validator to use for the flow. Next to that, we give it an ID and a secret and a set of allowed scopes. There's nothing new there. So that is all at level of the identity provider. And I think you're starting to see why I am not typing all of this ad hoc. It would become quite a lot, and even more after this. So that is all at level of the identity provider. But then at level of API 1, we need to exchange the initial token for a new one. So that is why I have this multi-hop claims controller. That is actually just a controller that is going to call API 2. So what do I do then? Well, what I actually need to do is create this request, including the scope, obviously. So for that, I again use the identity model helper classes. Those are pretty cool and make it easy to do this. So I again get the discovery document, which we still remember. And then I create a list of parameters. The subject token type, the token, which is the access token, and the scopes I request. So this should start to look familiar. We're actually just building the request that was on screen, including the scopes. So we need API2.full access as a scope to be able to access API 2. And then I call request token async, which simply creates a request to the token endpoint. The address is the token endpoint. The grant type is again the one from the slide. The parameters are the other parts that were on the slide. And client ID and client secret are the ones I inputted at level of the identity provider. And what this should do, then again, call the second API passing through that access token we got. And we should then see a list of claims for who the user is or what is in the user object at level of API 2. Maybe we should have a look at what that entails. And it's loading. All right, let's log in. Bob, why not Bob? All right, and I'm gonna call the API multi-hop. And the thing we should see now, if everything works as expected, and it does, I hope, is that the client that accesses the second API is API 1. So we should somewhere see a client ID of API 1 client. Here we go. So this is effectively the client, API 1 client we defined at level of the identity provider, so which uses our custom flow. And we should also see that the scope or audience should be API 2 and scope API 2.full access. And I don't see the audience. Here we have audience value API 2. So this is effectively coming from the second API. We are still accessing that second API on behalf of the initial user that logged in. And we have used our new custom client related to the custom flow for that. So that is how you do multi-hop communication while keeping the current user. All right, let's stop this for a minute. And then let's go to the next part. And that is closely related to it. So we've now talked about user impersonation. Well, impersonation semantics, it's just the same user, but the semantics are the same. But often when you talk about impersonation, what that actually means technically is that, well, one person has access to a resource, say Sven, and I am going to act as Sven when accessing the resource. But at the moment I access the resource or the API no longer knows about Kevin. It no longer knows that I am actually accessing the resource. No, it thinks that Sven is accessing the resource because I identified as Sven. What this boils down to is that the access token that would access the API would have the subject value of Sven and not know anything about me, who is actually the user in front of the computer. That is impersonation. A bit more interesting than impersonation, in my opinion, is delegation. It's very closely related to impersonation, but it actually means that, again, Sven has access to a resource. I am going to access that resource on behalf of Sven, but the API would still know that I am accessing it on behalf of someone else. That is essentially what this means. So to get user delegation support, and this is often used in a lot of applications, you need something like this. Think about applications in which you need to be able to access the application in the name of someone else to be able to fix an issue. If you're working on a help desk, for example, this is something that comes up again and again and again. Well, you need specific semantics for that, by which I mean the identity token and access token need to contain a notion of who is acting as who. So we need to somehow expand the tokens that are returned from IdentityServer. This is, by the way, not a custom flow. This should work with any flow. We are simply changing what would be in the token itself. So to be able to do that, we would again use a part of the token exchange standard, and that part is the act or actor claim. And that is essentially a JSON object which identifies the user that is acting on behalf of someone else. So if I try to get back to the initial example we had, and let me think a minute about this, because this is something that always gets mixed up a bit. So if I want to impersonate or act as someone else, I am going to become the actor. So the subject value will become the user that I am not impersonating, but that is delegating access to me. So in this case, we would have a token that looks like this. The user is Sven. So the subject value, so the Sven is actually going to be the one that is signed into the application, even though I am the one behind the computer. But the token will have an actor value, which contains my identifier. So the application knows I am actually acting as Sven. It's not Sven who's sitting there, it's me acting as him. To be able to do that, we need to customize IdentityServer again. But as you know, IdentityServer is simply it's a framework which by default doesn't include a user interface. We add the user interface when we build a web application that integrates with the IdentityServer framework. Well, we are now going to have to expand that user interface to allow delegation. And I'm going to show you what we're going to work to, because it makes it a bit easier to grasp what we're going to do. So I'm going to show you the UI here, running in code, of course, that we will build. For that, I need to uncomment a little part. So we've been working with post back without delegation all the time. Maybe this is simply the code that is running when you click the login button at level of the identity provider. So there's a bit of error checking or cancel button checking, some error checking, your credentials are validated, and eventually, if all checks out, you are signed into the identity provider. So this actually writes IdentityServer session cookie. There's nothing special here. This is the default IdentityServer code. The rest of it is a bit of checks to where you should redirect. And that's it. This is default IdentityServer code. And we are now going to stop using that. So let me put this in comments. And instead, we're going to use this one. And I'll immediately run to it, but I'm first going to show you what it is going to look like. And that will be a bit easier to grasp. So let's start this up. While this is running, I'm quickly going to turn on the lights here because I'm starting to sit in the dark. All right, I can see again, and I see the application is started. Let's try Bob again. And this is the additional screen I built. So at this moment, I'm going to be able to select a user I want to act as. So let's say I am Bob and I want to act as Alice. And there we go. We are now in the application again as Alice. Now, of course, as you see, not everything is in place yet. If you look at this claims list, there is no notion of Bob anymore here. So we do have a bit of work, and we will look into that. But first, let's have a look at how I got to that additional screen. So it's essentially just ASP.NET core code, obviously. So what I did was the login action has changed a bit. So the first part still the same. And the second part, I'm still validating my credentials. I am again finding a user, so whether or not I exist in the database, that is quite important. But the idea is that if this checks out, I am now going to redirect to that user delegation screen you saw. So to be able to show that screen, I need a bit of information. So that screen requires my subject ID, it requires my username. It always requires the return URL. So these return URLs in IdentityServer, they help with flowing from one part of the flow to another part. So from one screen to another screen. So essentially, I am going to create a cookie here that contains the information I'm going to need on the subsequent screens. By the way, why a cookie? This might also be important. You could pass through this information via the URL as well, if you really want to do that. But the thing is, if you pass it through via the URL, it can be manipulated. By storing it in an encrypted cookie, and I'm using the data protector, so the iData protector interface from ASP.NET Core for that. So this writes an encrypted cookie that can only be decrypted by the server, which is pretty good. So by doing it like this, you make sure that this information is safe and cannot be tampered with. So that is why I prefer to use cookies to exchange data, especially for an identity provider, to exchange data between screens instead of using the URL, or at least for sensitive data. So I simply write a cookie to be able to continue with the next screen. So what happens then is, well, I'm going to call a method, execute delegation when applicable. Let's go to that method, because this is the one that is going to decide whether or not the screen should be shown. Now, this is something I simply put in here, which you can change if you want. In my demo, I simply always show this in between screen. But for real life applications, you would probably want to decide on whether you can execute delegation. You don't necessarily want to allow this for all applications. So depending on the client app, you can show it or not. You can also check whether or not you can act as any user. You might not want to allow that as well. You can do that here as well. So this is just a method I put in between in which you can implement that logic in case you need that. In our case, it's okay. So we redirect to the user selection page, and that is actually the delegation page. So regular ASP.NET Core, you have a delegate method on get and a delegate method on post. The delegate method on get reads out that cookie I created and protects it, parses it, and builds a delegation view model from it. What is in that view model? Well, let's have a look. Oops. That's the login delegation view model. A list of potential users and the current user. So that is that list you saw on screen and the current user you saw on screen. After someone has selected the user wants to act as, we handle the post back from delegation. So again, we read the cookie and protect it, and then we can start saving the data IdentityServer will need. So IdentityServer now not only needs to sign in as the user I selected. So I logged in with my credentials, but I need to sign into IdentityServer with the user I'm impersonating, I'm delegating access to, because that is also the user that will be needed at level of the client application. So that's the first thing I need to do. I need to switch those two around. And I also need to keep a notion of who I am. So I need to get the actor, which is me, the user that initially signed in. So this is where those values are selected. And then I continue to the method that actually signs the user in. So now we're near the end already. We're near the part of the application where identity service cookie is created. And this code is pretty much like what you saw in the initial post back method for handling the logging. So I pasted a part of that method here, which is all of this code. This is simply coming from the original code. But what is changed here is that I'm creating signed in user a bit differently. As mentioned, we need to switch the subject around, and we also need to add something being the actor claim. So I need IdentityServer as well to know that someone is acting on behalf of someone else. You need that. You need this information at level of IdentityServer as well, in case you need to know that for other parts of your application, of your flows. So it's not only the client application that needs to know I'm acting on behalf of someone else, you need that information in IdentityServer as well. So that's why you write that as an act claim. So this is actually the value that's going to be put in the actor claim, which is stored at level of IdentityServer, which is the user at level of IdentityServer. And afterwards you sign in with that. So this is essentially it. This ensures that the user at level of IdentityServer is now someone who's delegated access to someone else. So that is how you do that, how you create that screen. So let's have a look. Wait, yeah, I'm gonna have a look again. This is more or less what we just saw. All right. Should be coming up any minute now. There we go. So let's log in as Bob again. And let's act as me. Oh, why not? And we end up at where we ended up before. So the thing is, we have now effectively seen that at level of the identity provider, we have created an identity including the actor claim. But if we look at the claims here, there is no actor claim. This is me, the user that's being impersonated, but the fact that Bob logged in is now missing. And if you look at the content of the identity token, which is where we would expect the information to be, in the identity and access token, by the way, we see that there is no actor claim here. The subject value is my subject value, Kevin's subject value, and the rest of the information as well. So something is still missing. Somehow the actor claim doesn't come from IdentityServer to the client application. Now you can solve this in different ways. You could have the client application request that scope, for example. Create a new actor scope, allow the client access to it to request it. But in my opinion, that's not really what you want to do because you want to always add this actor claim, just like you would always add an expiration claim and a scope claim to your tokens. This is user delegation internals. For those things, it's not the client who should decide on that. You, the identity provider, decides on that. And how do you do that then? Well, you do that with a custom profile service. So the profile service, for those who don't know it yet, but I think most of you will have used something like this when you've worked with IdentityServer. This is where you would implement the method that allows you to get additional data on the user, which you can then put into the tokens that are delivered to the client. So what in my case I want to do, and this is more or less the same code as before, I want to get the current actor and I want to load information about that actor. So I can get the current actor because IdentityServer knows the actor from its own session cookie and its own user. So I can get the current actor and I want to put the actor claim, here we go, here, that's this part here. I want to always add the actor claim to whichever token is returned. So this code, which is simply a bit of getting the data from the existing session, loading some additional claims and putting them as actor claim in the tokens. This is the code that ensures that your client application now also knows what your identity provider knows. Of course, I have to enable it. So I do that in the startup. Oh, add profile service, the delegated profile service. Now this profile service will automatically be used. So let's start this up. Now we should start seeing a few different things here. All right. I'm going to log in as myself. What is my password? It's not password. Maybe Kevin. It's not Kevin. Forgetting your own password. Let's have a look. My password, lowercase Kevin. All right, sure, why not? Don't save. All right, so I'll log in as myself. So I am the user behind the screen, and I want to impersonate Sven, which follows the example from the slides. And now let's have a look at this identity token. There we go. Sven is the subject value, the current user who's logged into the application. Here's an actor, which is me, so I am acting as Sven. The client application can now know who is acting as whom. An interesting fact, by the way, the fact that these claims show up, these only show up because the client application requested the profile and email claims. So again, even with all this custom code, it would still, IdentityServer still follows the scopes and thus claims I requested. So that is pretty cool, I think. But let's see what happens if we call the API. And here too, we find that actor claim. So even the API and even the access token contains that actor value. And this was, by the way, a reference token call. So it's pretty cool how all of these things tie in nicely together without too much effort. So we extended IdentityServer a bit, but we did not break anything of its normal way of working. One more interesting thing for this part is that we now also have an act claim here. This is something that is a bit special. This doesn't just show up. We have to code a bit for that. And I'll show you because actors, this isn't new and this isn't OAuth related either. If you've worked with identity and claims claim stuff in the past in your applications, even without OAuth and OpenID Connect, Windows Identity Foundation, for those of you who've been around for a while, the actor claim already exists for a long time. It is how user delegation has been implemented from before OAuth and OpenID Connect existed. And you can actually see that because if we look at, can I get a claims identity somewhere else? Let's see, I'm just gonna access the user here. User dot, where can I find that? Identity dot claims. Where is it? Oh no, I know where it is. Wait, wrong part of my code. Oh, here we go. So every claims identity actually by default already has an actor property, which is a claims identity again. So this is not something new and it's not OAuth and OpenID Connect related. It just takes a bit of effort to get the actor claim to be filled out. But essentially applications that work with delegated access already should work with the actor claim. We now just fill it out in a different way. And that is a bit, this is somehow, I still don't know where this was coming from, but by default, ASP.NET Core and the old ASP as well will try to look for an actort claim somehow. It will look for that, and if it finds such a claim, it will create a claims identity from that and set that as the actor for the claims identity. I still don't know where this is coming from. It probably has something to do with some sort of backwards compatibility. But anyway, we do not have an actort claim, we have an act claim. So what this code does is it simply gets the information from the act claim in the token, and it creates a new claims identity for that, which it then sets as the actor. So with this little piece of code, your claims identity now has an actor, as it always used to have in older scenarios. All right, that is it for user delegation. I kind of like this feature. I kind of like how new standards still nicely tie in with what we used to do. And it's always nice to have something like that, that we don't have to make this up. It exists. We can simply use it. All right, on to the last part, and that is an improvement of client authentication. So we all know client ID and client secret, right? That works. Client ID and client secret are used for authenticating the client application itself. So it's essentially the client's credentials. And it's a pretty basic form of authentication. It's essentially username and password. And that might be okay for some applications, maybe for internal applications, let's say inside of your company walls. That's pretty great. Why not? But it also has a few disadvantages. There is essentially no verification of who requests the token, other than anyone possessing the client ID and secret. So the identity provider cannot assert the identity of the client requesting the token. Any client can have done that, or rather anyone can have tampered with the request between client and API, client and IDP. So the request itself is not, or the identity that makes the request itself is open for tampering with. And that is essentially because it has not been signed. If you would be able to sign the authentication logic, so if you would be able to sign the client secret, let's say, something better than that, then the identity provider would be able to verify that the request or the client authentication has not been tampered with between where it came from and where it ended up. So it means that the identity provider can be sure that the request is coming from the correct client. So that is why we need a better way of authenticating clients. Client ID and a client secret are great for simple things, but I wouldn't really want to provide tokens that give access to sensitive information. Third parties, for example, that need to access your API with a simple client ID and client secret. So this is something that's also implemented the few of my clients. And this is something you would typically use if you want to expose your APIs externally. So if you want to expose your API to a third party, it would be a good idea to have them use a better means of authentication than a client ID and a client secret. And that is where private key JWT client authentication comes from. Again, this is not something we have to make up ourselves. It is an existing standard. So the standard is on screen, and it essentially describes how to use JSON Web Tokens for client authentication. And we are actually going to create a token now that we are going to use instead of a client secret. And we're going to sign that token so the identity provider can verify the signature and know that it hasn't been tampered with. So that is what is called private key JWT authentication. And it's becoming more and more prevalent. I see it more and more in the wild, let's say these days. If you're in Belgium, I can only talk for the Belgian audience in this regard. In Belgium, we have a digital ID. It's called It's Me. which is essentially an app on your phone which you can use to authenticate with a lot of government services. They also use OAuth and OpenID Connect, and they, for example, require something like this. They even have some additional encryption as well, but you cannot integrate with It's Me without using this type of client authentication. So it's becoming more prevalent, especially if you need heightened security. How does that look like then? Well, we're essentially going to create a new token. And that token looks like what you see on screen now. So I am going to create a token to access the API. So GTI on screen here is just that's an identifier, the identifier of the token. Subject value will be the client application that creates the token. So this could be API1 JWT client, it could probably also be our web client. So this is a client we again have to create at level of the identity provider, obviously. Issue that not before expires, you all know that. These are times we input ourselves now. So we create the token, so we also input these times. The issuer is again the client application that's going to request an access token. And the audience, and that's important, is the token endpoint at the level of the identity provider. Because that token endpoint is where we are going to send the request to get an access token. All right, let's see how we can implement that. So first things first, we're going to create a token. So I'm in the home controller, and you've already seen that get token with private key JWT part on screen, button on screen. So again, I get the discovery document because I need to know what the token endpoint is. And then I'm going to create a signed token. I have created a helper service for that, a token generator. And it has one method, create signed token. I input the client ID. We will immediately look into this. This is a new client as configured at level of the identity provider. And I input the audience, the token endpoint. So let's go to the definition. Oops, sorry, go to implementation is what I need. Let's go to the implementation of this. All right. So what you see here now is essentially that I am creating a new JWT security token that matches these values. So it's what we've seen on the slide, but in code. So I pass through an identifier, the client ID as subject, issue that, which is the current time. This is not before, and this is how long it's valid. And I also input the client ID, which I got from here. So our client and the audience, which is the token endpoint. That's this. Then we need to sign this token. So for signing, I typically want to use a certificate. You can use a certificate. You can use hard-coded JSON web keys, JSON keys for that as well. I've used a certificate. You can use anything you need. So I created a simple PFX, which contains a private key and a public key. So if we add a set of signing credentials to the JWT security token, this, by the way, are default ASP.NET Core classes. So they're built in. It's no non-Microsoft package. This is all built into .NET Core. So we create a new set of signing credentials, passing through the certificate we want to sign with and the algorithm. And if we then execute write token on a new token handler, this will effectively write this token and use these signing credentials to sign it with. So it will use the private key from our certificate to sign the token with. From that moment on, we have a signed token. And that signed token is then used to access, to authenticate myself, to authenticate the client. To do that, we now need to call the token endpoint to get an access token. And again, this is a client credentials flow, by the way. That's just as a simple example. This is a simple client credentials flow, which will give me a token without any user involvement. So this is a simple example. I call request client credentials token async. I pass through client ID, the scope I need, and then this is the new thing, I pass through an assertion. And the assertion contains the signed token as a value, and the type is JWT bearer. So which essentially means the token that is passed through is the one that contains all the information you need to verify the client in this case. So bearer is contained within the token that's passed through. That's more or less what that means. So from this moment on, I should get back, after calling this, an access token. And then I use that access token to call the API. So we will immediately see that. So this is all the code that's needed on the client. But obviously, we still need the code on the identity provider. So again, to the config class, what was it called? API1JWT client, I think. So this is essentially a client credentials client. Pretty easy, one allowed scope. And you see that instead of a client secret, if you would look here, you have client secret defined as such. It is now defined as such. And what this is I'm saying that the secret is certificate based, which is true because I'm passing a certificate. And this value here, well, that is effectively the full base64 encoded certificate. So if I would export the PFX file without private key, because you only need the public key, the identity provider does not need the private key to verify the signature. So this is essentially just an export of the signature, an export of the certificate I used to sign, which only contains the public key and is base64 encoded. So that would be a CER file, which you then simply open in Notepad and you paste it in here. You can also, by the way, load that from a file if you want. This is for demo purposes, this is a pretty nice way to solve this. And like this, the identity provider will know enough. Now that alone is not enough because by default, IdentityServer does not expect a secret to be a private key JWT. So you need two additional things. You need an assertion secret parser, which you simply need to register. This is built into IdentityServer, by the way, so you can just add this. This is a default parser that will try and get the token from the bearer assertion as it's passed in, as we saw on the client. And then normally you would write this. Add secret validator, private key JWT secret validator, also built into IdentityServer, and it will validate that token that's passed in. The thing is though, this is a small bug at this moment. It didn't exist. The bug didn't exist in IdentityServer 4 version 3. It does exist in IdentityServer 4 version 4. Essentially, the people that are building IdentityServer want to implement some sort of caching in this validator, and they checked in a bit of code that's but forgot to register the cache that is used inside of it. So this will no longer, this service will no longer be able to be constructed. So I created my own JWT secret validator. Let's have a look at that. And this is essentially a copy of what was in IdentityServer. And this will simply, boom, here we go. It will validate the passed-in token. So again, we have validate token with the token validation parameters, which contain the key used for signing, in this case, the public key. So this is simply validation of the incoming token. The issuer, the audience, all values we passed in at level of the client that are now validated at level of the identity provider. And like that, it should work. So let's give that a try. There we go. All right. Bob, Alice. All right, client authentication with private key JWT. Let's try that. This calls the API as we've seen. And here we go. We have a result from our API call. We don't see a sub value, but we do see, which makes sense, this is client credential flow, but we do see that API1 JWT client was used. In other words, the client which requires the private key JWT as client authentication. So this is how you make a more secure call, a call with more secure client authentication. And there is one more thing. I already added a few things to this session, but I also added a completely new part because, well, this is all nice. So heightened client authentication, it's all nice and great, but this is a client credentials example. But you can imagine that you would also want to use this for your code flow. So for your login grant, your authorization grant. If you look at it now, where is it? My startup. So if you look at how I implemented this is a code grant with Pixie protection, by the way. And I simply use a client secret, a fixed client ID and a client secret here. This can be okay, but well, client authentication, improved client authentication can actually be used wherever you would normally use a client secret. So you can also improve your authorization flow, your authentication flow. And let me show you how that is done. Now, see that I do this correctly. Because this is a bit special, and that is why I want to show this to you. You would normally say, well, I somehow need to be able to pass in. We need to be able to write that token. I need to create a token that is used for client authentication. And well, the problem then is that at this point in my code, I'm in the configure services method. And in the configure services method, I cannot reliably create an instance of my token generator, for example. I have used that token generator to create a token. I would like to reuse that, and in any case, whether or not I reuse that or not, the issue remains the same. I cannot inject that code here reliably. Well, we used to be able to do that, so I had it as a singleton, and then you used to be able to write code like this. So in your configure service method, if you need an instantiation of a method registered on your container and you need that in your configure services method, you would do it as such. You would create an in-between service provider and get it from there. For example, with an HTTP client factory in this case. I need that HTTP client factory, by the way. So that's why I use this as an example. That is no longer possible, or at least it is possible, but it is a bad practice. If you write code like that, you will get a nice little warning saying that if I remember correctly, if you do something like that, all singleton services will by definition be created twice. So you would end up with more instances of your classes on your container than you would want. So how do you do this then? Well, you use the post configure options. So the OpenID Connect options are what I set here. So these options, the same types, OpenID Connect options. And what I'm essentially saying is, well, I'm going to configure them like this here in the configure services method, but some part of the configuration I need to do afterwards when the application is already running, after the configure services method has been created, has run. So for that, you write code as such. I post configure options, and you can do that with all option objects, by the way, not only with the OpenID Connect options. And then I created a new class for that. So this is an implementation of iPost configure options for the OpenID Connect options. And it is here that I'm going to, again, this code will look familiar. I'm going to get the discovery document again, and I'm going to create that signed token. And then to be able to send it through, I cannot set options.secret, as you know, as you've seen. Client secret is a string. I cannot set that to the token and the assertion. It actually needs to be set. But as you know, when you're working with OpenID Connect, the middleware allows for very, very extensive configuration extensibility. So you can handle events. Each little piece of the flow can be handled and changed. So in this case, what am I doing? Well, after an authorization code has been received, which means right before the token endpoint has been called, is going to be called, I'm going to change the token request a little bit. I am going to create that token, and I am going to set the client assertion type and client assertion on the actual request to the token endpoint. So this means that the token request executed by the OpenID Connect middleware will now contain our signed token. And then the only thing that's left is the configuration level of the IDP. And that again looks quite familiar. This is exactly the same as our web client. So here we have the web client. Now we have a web client JWT with one notable difference, and that is that the client secret is defined just as it was with our client credentials flow. All right, let's give that a final try. Let me log in. Myself, why not? And there we go. I am logged in again this time, but this time I have used, I think I can even see that. Just in case you don't believe me, I can always prove stuff like this. So let's see. We can see that web client JWT was now used for the initial authentication flow as well. And I'm still signed in. So this was my session, actually. You've seen there's a lot of ways you can improve the default security with OpenID Connect. There's even more, there's more than this. And there's always new standards on the way. So this is kind of fun to be playing with. But if you implement the things you've seen in this session, I think well, you should already end up with a pretty secure application. All right, just to repeat, you can find all the demo code on my GitHub, which is on screen.